Power is an imbalance between input and output. In particular, you have a small input and you acquire a large output. This means you have power. Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert D. Nameland, who has been the greatest living philosopher before me. Let's talk about power, and without further ado, I will say that power is some sort of asymmetry, some sort of inequality. Power is a phenomenon of having leverage of some sort, of some particular sort, in fact. The leverage of the sort when you make a small action and it leads to big consequences, alright? Something like that. You may remember my older video, the Archimedes' lever of speculation. Watch the link in the description, where I talk about how speculation is this sort of leverage. Well, in this video of mine that you're currently watching, I'm kind of trying to generalize it to power in the first place. So imagine this example. It's Victorian era England, like the British Empire, and a person like snaps their like some well-dressed person snaps their fingers in London, not literally, metaphorically, and then half the world weeps because of this, alright? Or in a present day, some well-dressed guy makes a small, something with an ink on a paper, and it changes the behavior of billions of people. For example, if this guy was some sort of like a serious official, like I don't know, someone at the Fed changing the proverbial interest rates, all right, and it would influence pretty much everyone in the world in this way or another, right? What does it mean? It means that this guy in London, this guy at the Fed, they both had tremendous power, all right? And this is what we're talking about here. This is sort of like a true butterfly effect. The butterfly effect is when a butterfly flaps its wings in one place, and then like, I don't know, a week later a hurricane appears somewhere else in the world because of the chaotic dynamics. But here I'm talking about power in general, which has nothing to do with chaos, in fact. In this respect, it's not a butterfly effect, but it's still a funny metaphor anyways. So, from this, what it follows is that there is a certain imbalance leading to this effect. This imbalance is exactly what we call power, okay? In the imbalance between input and output. Small input, large output equals power in between them. Okay, so in the world of physics, we're usually dealing with equations. And if the expression world of physics confuses you, I'll remind you about my video Perpendicular Worlds, where I talk about the world of physics, where chaos increases, the entropy rises, and the world of meaning, where order increases and entropy decreases, right? And I call them perpendicular worlds because they actually intersect in some places, but they're fundamentally different, all right? So we're talking about world of physics right now. So we're dealing with equations in the world of physics with some sort of equality, right? We have conservation laws, we have all kinds of symmetries, we have one lump of something rather equals one lump of something else, right? This is a typical situation we have in physics. We write down an equation. What does equation say? One thing is equal to the other, right? There is no imbalance. In fact, this is perfect balance. Energy is conserved. So energy today would be the same as tomorrow if the system is closed. Mass conserves, not quite, but you know what I mean. Time, we can equate velocity, like whatever, like floats your boat, whatever is the situation you're dealing with equations most of the time, alright? Action equals reaction, the famous formulation of Newton's third law, which is incorrect, by the way, but, this formulation, but, let's not get sidetracked. Like, given our definition of power, my definition of power that I gave you above, it's only true that action equals reaction, or one side of the equation equals to the other in physics, if there is no imbalance. If the actor that we're dealing with possesses no power, then indeed the amount of input is equal to the amount of output, alright? There is no imbalance. However, as living beings, we're not only the part of the world of physics, we're also part of the world of meaning, alright? And the equalities exist in the world of physics per se, like taken on its own. However, this world of meaning may also impact us, and as living beings, it's actually easy to notice. For example, remember the words of Nietzsche: wherever I found a living thing, there I found will to power. And what did we just talk about? That power is imbalance. Power is not an equation. You cannot like reduce it to an equation, right? It's small input, large output. It's not an equation. You cannot equate those things. Then we have Erwin Bauer, who in 1935, I think, in the Soviet Union have published a book called Theoretical Biology. So what he said about life is that life is a stable non-equilibrium, meaning like a living being is in a state of a stable non-equilibrium. So what does it mean? Well, it's kind of like what we in present-day biology call homeostasis, right? Some sort of like stable state, but which is not in the equilibrium with the environment, right? This is what we're talking about. So in order to sustain this sort of overhang over the environment, for the lack of a better word, metaphorically, obviously, we need to do something, right? We need to be something else other than non-living beings. So in my eyes, it means that we actually are at the intersect of the world of physics and the world of meaning. Like, non-living things are world of physics pure, right? They don't have this connection to the world of meaning, even though maybe they do. Again, I gave you some hypotheses in this video of mine about perpendicular worlds. And here, with regards to this video, I suspect, and it's sort of my working hypothesis, once again, give you a tour of my workshop, so to speak. So I suspect that whenever a world of meaning intersects the world of physics, so we're dealing with something like that, you may have a problem with calculations, talking about numbers, talking about equations. By the way, watch my video about how numbers relate to the world. So in this intersection, our equations may break down, which naturally forces us, like we're not really left with anything else other than working with inequalities. Not equalities, but rather inequalities, right? So, in fact, you may formulate a stronger hypothesis, even though I'm not even sure if it's correct or not. Like it's a necessary, perhaps, again, perhaps it's all like, maybe it's all in the working stage. Maybe it's a necessary but not sufficient condition for tracking those intersections with the world of meaning. What is inequalities, basically. So, whenever you see an inequality appearing in physics, or maybe some other sciences that are tangential to physics, such as chemistry or biology. So whenever you see inequalities appearing, this is necessary. So probably you may be somewhere near the intersection point, even though that's not guaranteed. That's why I say, so not all inequalities mean this intersection, but this intersection cannot happen unless there is an inequality of some sort. At least this is my working hypothesis at the moment. So necessary but not sufficient condition. So inequalities represent the fact that we do, or we may have at least, certain leak into or from the world of meaning, right? So we say, well, we've had this amount of energy in the closed system yesterday, and today we have the same amount of energy. However, if the system is not closed, yesterday we've had this amount, and tomorrow we may have more or less or the same. Like, you never know, right? If there's a hole in your enclosure, right? Energy may leak in, it may leak out just as well. So by the same reason, for the same token, like if you have a world of physics where you have equations, if there is some sort of leakage through this connection with the world of meaning to it or from it, you are kind of left with only inequalities. You may say, well, today we have X amount of thing, and yes, tomorrow we'll have less than or equal to X amount of thing, in case X thing leaks into the world of meaning from the world of physics, right? Something like that. Or vice versa for leakage into the world of physics from the world of meaning. Hopefully you get the idea, even though I apologize for being perhaps way too abstract. So, what are the examples of this sort? Well, for example, like dealing with inequalities and things like that, there is a common phrase, you know, something like, a whole is bigger than the sum of its parts. And, you know, it's used in this sort of holistic approach to reality, right? But you can hear literally in this formulation, like, the whole is bigger than the sum of its parts. It's an inequality, right? So a whole is bigger than the sum of its parts. So you can't just sum up things and come up with a sum. In case the world of meaning is involved, the whole, which means something else than the sum of its parts, would become bigger than the sum of its parts, right? So this is what I'm talking about. It's a typical invasion, I would claim, of the world of meaning into the world of physics. And perhaps, again, another hypothesis, structure formation in general may be a symptom of this sort of, you know, being somewhere near this crossing of the two worlds. I don't know. So it doesn't necessarily, this sort of leakage, this sort of connection, again, Hermes, right? Hermes is a messenger between two worlds. So it doesn't mean that you cannot derive any laws, but you simply cannot formulate them as equalities. That's kind of the only thing that's happening. What are the other examples? Well, again, famously, second law of thermodynamics, right? It's formulated as an inequality, which again kind of gives us a hint that we're dealing with some sort of hermetism, right? Or hermeticism, like some sort of stuff dealing with one of the two worlds or their relationships with each other, rather like the world of physics as it relates to the world of meaning, right? Something like that. Hopefully you can understand what I mean, even though, again, I'm being a little bit too vague, perhaps. Then we have Landauer's principle, which is basically the way of recalculating information in terms of energy, which, again, in one of the previous videos I've stated, like, it allows us to really derive energy, like mass energy information equivalence, right? Not just mass and energy, E equals mc squared. We can also add information to it, because per Landauer's principle, there would be a heat released if you erase a bit of information, and heat is energy, so you can equate the information to energy. But then again, it's formulated as an inequality, which once again hints that maybe we're dealing with some sort of leakage between two worlds, all right? And by the way, some people have relatively recently, like 15 years ago, it has been proven that Landauer's principle is a direct consequence of the second law of thermodynamics. So it doesn't have a sort of like an independent character to it. As long as second law is formulated as an inequality, Landauer's principle would also become an inequality. So they're kind of the same thing, really, if you think about it. Then what do we have? What other interesting inequalities do we have? Well, Heisenberg's principle, right? The uncertainty. It is formulated as an inequality. So what does it give us a hint about is then again that there might be some sort of leakage already at the very small level, at the quantum level, all right? You may remember one of my videos, like the onion of aliens. I don't remember which part it was, so I'm gonna link all three. You know, they're like more than an hour long, each one of them. But there I talk about aliens in a lot of detail, like philosophically. Okay, I'm not talking about UFOs or things like that. So, like, what kind of otherness there may be in the universe, basically. That's kind of the question I'm asking. And there I mentioned that, if you think about it, the fact that we cannot describe the position and momentum or the energy and time, for example, simultaneously for these small particles, it kind of hints that they have a free will of sorts, right? Like, we can pinpoint their location, but then we wouldn't know where they're going and how fast they're going, or vice versa. If we constrain the velocity, we would never know where they are. So they kind of have a free will, if you wish, you know. They have a certain degree of freedom to use, like, which we can never fundamentally know, which is kind of curious, right? So, I mean, free will kind of indicates the world of meaning, like that there's something non-physical happening here. Non-physical meaning, you know, physics in the regular sense of the word, like materialistically, all right? So, yeah, curiously, there is this sort of thing. Then Bell's theorem, again, continuing with quantum inequalities, it describes entanglement, right? And it is also formulated as an inequality. So entangled particles, they're like this whole that I've talked about just now in terms of holism. The whole is bigger than its parts, and therefore two entangled particles is more than just the sum of two particles, right? It's something else, something entirely different. Therefore, we can only formulate a statement about such an entangled pair as an inequality. We just can't do anything else, okay? We can't use equations for this. Okay. These were examples. I mean, you can probably find much more, many more, but, I'm limited by my temporal resource, so to speak. So let's move on. And I'm kind of getting very close to the end here. So what I want to discuss quite briefly right now, the paradox of our civilization, paradox of humanity, if you wish. You see, we like working with equations. We like our neat physical laws where energy is equal to previous energy or mass is equal to previous mass, even though it isn't, blah, 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 blah. You get where I'm going with this. So because we can operate with them really easily, right? They allow us to calculate a lot of stuff. They allow us to estimate a lot of stuff, etc., etc., etc. So we love equalities, right? However, as beings striving for power, again, see above the quote of Nietzsche, what we really want is inequalities. We want to have a small input and to have as bigger of an output as possible. We want to have power, right? So fundamentally, we study nature as if it is filled with equalities, and we want to be the unequal to nature, right? We want not to be present in this equality. We want to be above it. Again, this sort of overhang that I called it, right? We want to be at the longer side of the lever, so we can apply small force and get a big force as a result of it. All right. So yeah, this is kind of a paradox of our civilization. I'll give you just one example. It's very simple. Like, for example, if I spent the same amount of energy mining coal as the coal would give me when it burns up, it would be kind of pointless for me to mine coal. However, it's actually very cheap energetically to mine coal compared to how much energy the coal gives you if it burns up, alright? So small action, we're mining coal, big result, a lot of energy that the coal releases when it's getting burned. So this is the inequality I'm talking about. This is the inequality that feeds our civilization, that feeds humanity even without civilization, really. So yeah, and so we are forcing to some degree nature to abide equalities because we don't want nature to have power over us. However, we want to have power over nature, and on our side we would like things to be as unequal as possible, if that makes any sense. All right, and arguably the progress of civilization is exactly that. It's the lengthening of our end of the lever. We're getting more and more leverage. The smaller and smaller our input becomes, and the bigger the output becomes, okay? So yeah, or life gets easier if you formulate it in a very trivial kind of manner. So yeah, there is, of course, the concept of potential energy, and this is a bit of a tangent to what I've been talking about previously in this video. However, watch my video, Potential Energy and Other Dark Matters, where I just talked about how we almost like force nature to abide the equalities. Well, there are many cases where nature doesn't abide any equalities, and we force it to do it. For example, as I've talked about in this video that I just mentioned, we introduced the concept of potential energy. And potential energy is like it's filling the gaps where you know, there was an inequality, but we plug the potential energy into an inequality and we get an equality and everyone's happy. And for example, the conservation of energy was under huge threat when beta decay was studied, and people discovered that the spectrum of beta electrons is continuous, and there was a pretty big school of thought spearheaded by Bohr himself, who said maybe energy is not conserved in this process. Maybe the equality of energy is impossible to write down. And then people said, no, shut up. We'll plug some extra stuff in there and it will become equality again. And that's how neutrino appeared. Okay, so we've invented neutrino. We've plugged the hole in our law of conservation with a new particle, and then everything became hunky-dory. Okay, and speaking of dark matters, I mean, this video of mine is called Potential Energy and Other Dark Matters. This is how dark matter was introduced, right? And which I mentioned in this video as well. But could it be, as I've mentioned in my video Perpendicular Worlds actually, that gravitationally bound systems are also the places of this sort of intersection? Like in that video about perpendicular worlds, I claim it could, okay? In fact, I almost factually state that they are. But maybe that's why our gravitational, our description of gravitation is so bad. Maybe it's because we can't really write down equations for gravity. Like we're trying, sure. I mean, Newton is the most famous example, but Newtonian gravitation doesn't work in galaxies. It cannot describe the rotation curves. That's why you need dark matter. You're again plugging the hole with a new concept. What if it's not the case? What if it's just a symptom of inequality in gravitational interactions? Like there are plenty of indications that there is something weird about gravity. Like again, speaking thermodynamically, right, the gravitationally bound systems have negative heat capacity, and it's kind of like insane to think about. Like it's so unusual, right? So there is some serious leakage. There's something fishy going on, okay? And not just in galaxies, by the way. Newton's gravity doesn't work in wide binaries and many other examples as well. So maybe we should try formulating gravitation as an inequality. I don't know, it's just an idea. I mean, the Machian gravity is a pretty cool concept as well, but I don't know, it's all work in progress, okay? So let's conclude. What have we talked about in this video? It was about power, and again, I once again expanded on my vision of perpendicular worlds. So my definition of power is that power is an imbalance between input and output. In particular, you have a small input and you acquire a large output. This means you have power. However, this is the case in, like, we're pretty much, as a society, we're anchored to the world of physics right now. We're a very materialistic society, right? So we perceive power in this sort of way. Like a small physical action, big physical reaction. However, is this, and this is a PS, philosophical PS to this video, is this the case in the world of meaning? So, is power defined as, in the world of meaning, I mean, like the reverse, as a huge output versus small input? That's kind of an interesting concept, right? For example, a religious altruism seem to hint heavily towards this, right? So what is perceived good in pretty much every religion there is to do as much as you can for others while receive as less as you can from them, right? This is the religious power, and religion deals with other worlds, right? With the world of meaning, essentially. The invisible world, the gods, the demons, the angels. So entities from the world of meaning. So this is really interesting. So we may perhaps formulate a tentative hypothesis that in physics, maximum power means infinitely small action leads to infinitely big result, whereas in the world of meaning, maximum power would be infinitely big action leading to infinitely small result. So it would be kind of the reverse, right? So the power in the world of meaning is absolutely the absolute powerlessness, if you think about it, in our world of physics, and vice versa, by the way. So in the world of meaning, if you perform the absolute infinite action, you get absolute almost zero response for it, right? Which makes you the God, essentially, if you think about it, right? The God is the, well, I mean, this singular, the God, that's why I call it the God, has infinite power, like maximum power. And the God literally created everything. So maximum, infinitely big action. And what does he or the, she, it receive in response? Well, pretty much nothing, right? So this is maximum power in the world of meaning. I think it makes sense at the very least. Well, something for you to think about. Thank you for watching. The eons are closing. If you wish to support me, please consider joining my Patreon. That is patreon.com/philosopher. See the link in the description. Or if you have a scientific theory of your own and you'd like my help in developing it, please join my alternative science coaching program, also available through Patreon.